Good morning, this is C. Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. Today, I want to discuss about the solution of partial differential equation. In the last session, we have discussed solution of partial differential equation by using Lagrange's method. In that, we have two types. One is method of grouping and another one is method of multipliers. In the last session, we have discussed only method of grouping. While taking grouping, what are the solutions and how we can write the solution of the partial differential equation and all we have discussed. Now in this session, I'm taking solution of partial differential equation with the method of multipliers. This is also Lagrange's method. In this method, I want to choose the multipliers. By using multipliers, how we can find the solution. So solution of partial differential equation by using Lagrange's method of multipliers. So in the last session, we have discussed the method of grouping. Grouping is nothing but after writing the subsidiary equations or auxiliary equations, so we can equal any two fractions, while 1, 2 or 2, 3 or 1, 3. What are the subsidiary or auxiliary equations? Dx by p equal to dy by q equal to dz by r. This is the subsidiary equation or auxiliary equation. Now from this we choose any two fractions from this equation, either 1, 2 or 2, 3 or 1, 3. By grouping, we find the solution. After integration, we'll get the solution. Sometimes which is not possible to consider by taking grouping. Nothing but by taking any two fractions, we cannot take the integration sometimes. In that cases, we have to choose multipliers. What are the multipliers and how we can take the multipliers and all we have to discuss in this session. Method of multipliers. What are the multipliers? Suppose I am taking LMN. LMN are nothing but either functions of x, y, z or sometimes constants or sometimes zeros, whatever it is. So LMN are nothing but here we call multipliers. So choose any three multipliers LMN, may be constants or functions of x, y, z. LMN are nothing but multipliers, small l, small m, small n. So these are multipliers in this throughout the topic. So first write the subsidiary equation or auxiliary equations. In the previous one, we have written subsidiary equations are only three: dx by p, dy by q, dz by capital R. Here we using multipliers and we can write one more fraction like this: L dx plus M dy plus N dz by LP plus MQ plus NR. So if it is possible to choose LMN so that LP plus MQ plus NR is equal to 0, then LDX plus MDY plus NDZ equal to, we consider 0, then take integration, then we'll get the solution. If it is not possible to take grouping, we can choose the multipliers. Those multipliers are like constants or functions of x, y, z. What is the condition here? If we take LMN or multipliers, definitely LP plus MQ plus NR is value is equal to 0. LMNR we have to choose, and capital P, Q are nothing but coefficients of small p, small q and r. So LP plus MQ plus NR value is equal to 0. Then we take LDX plus MDY plus NDZ equal to 0. After integration, this will get one solution. So definitely L should be either constant or function of x, or M must be y or constant, N must be z or constant. Then only we can take the integration. If we take the integration, we'll get one solution. So like that, sometimes here we have one solution is from grouping we can take, and another solution we can get by choosing multipliers, or sometimes both the solutions are we can choose multipliers. So If based on the problem, we will take either grouping or LMN or multipliers. Based on that, we'll get two solutions. Anyway, we want two solutions to take the partial differential equation solution. Write the general solution, which is of the form phi of u comma v equal to 0. So, this is the method. LMN are multipliers. We have to remember this one. LMN are multipliers, and those LMN are either functions of xyz or constants. Then only we can take the integration. And one more thing here we have to remember. If we choose LMN values, the denominator into L into P plus M into Q plus N into R must be equal to 0. Then we can take L dx plus M dy plus N dz equal to 0. Here we have to check only this condition, and to get solution we write L dx plus M dy plus N dz value equal to 0. If it is equal to 0, then only we take the equation L dx plus M dy plus N dz equal to 0. After integration, we'll get the solution. So, working rule to solve PP plus QQ equal to R. Anyway, these are all linear partial differential equations. So, first write the auxiliary equation. This is the first step. The given equation, if it is standard form, write the auxiliary equation. If it is not, you have to change the given equation into standard form. PP plus QQ equal to R. If it is standard form, take the subsidiary equations or auxiliary equations. Those are dx by p equal to dy by q equal to dz by r. P, q are nothing but functions of x, y, z. What is the second step? Solve the subsidiary equations by the method of grouping or by the method of multipliers, or sometimes both, to get the independent solutions. That is u equal to a and v equal to p. Our intention is to take two solutions, a and b. A is nothing but here u and b is nothing but v. The general solution is phi of u comma v equal to 0. U is the first solution and v is the second solution. So here we have one problem, y minus z into p plus z minus x into q equal to x minus y. In the previous session, we have simple forms pp plus qq equal to r, either x, y or y, z only. But in this we have y minus z, z minus x and x minus y. First take that the given equation is in the standard form or not. So the given equation is pp plus qq equal to r form only. So the subsidiary equations are dx by p. P nothing but here y minus z, and q is nothing but z minus x, and r is nothing but x minus y. So dx by p equal to dy by q equal to dz by r. So this is the subsidiary equation or auxiliary equation. Now, what is our intention? If we take any two fraction, we cannot take direct integration. So in that cases, we have to take the multipliers. So here I am taking the multipliers are L equal to 1, M equal to 1, N equal to 1. So what is the condition? If suppose I am taking LMN are 1s, how we write these LMN? One condition. What is that condition? LP plus MQ plus NR value should be equal to 0. So now we have to check whether LP plus MQ plus NR is equal to 0 or not. So L into P. What is L? L I am considering 1. P is nothing but y minus z plus z minus x plus x minus y. The denominator is here. We got 0. Nothing but LP plus MQ plus NR is equal to 0. Then we can proceed. If it is not equal to 0, we have to choose another multipliers. Will get LP plus MQ plus NR value must be equal to 0. So here we got LMNR 1, and if we take LMNR 1, we have the condition LP plus MQ plus NR value equal to 0. So that's why now we can proceed. So then take the integration. So what is the integration? Dx plus dy plus dz equal to 0. LMNR here 1, 1, 1. So we have formula that is nothing but L dx plus m dy plus n dz equal to 0. If LP plus MQ value is equal to 0, then we can write LDX plus MDY plus NDZ equal to 0. Now take the integration. Integration of 1 is x. Integration of 1 into y is y. Integration with respect to z is z. And we'll get after integration some constant, that is a. This will give the one solution. For the second solution, take another multipliers. So first multipliers are I am choosing L, M, N are 1s. Why I am choosing L equal to 1, M equal to 1, N equal to 1? If we take elements are 1, we have the condition that is LP plus MQ plus N are equal to 0. And in the next one, next multipliers also we have to choose other than 1, 1, 1. Already we got one solution with the multipliers 1, 1, 1. Then choose the another multipliers where LP plus MQ plus NR value is equal to 0. What is L, M, N I am choosing here? X, Y, Z. L is here X. M is here Y. N is here Z. We can choose either L or X or 0. M either Y or 0. N either Z or 0. Now choose those multipliers. What is the condition? LP plus MQ plus NR value must be 0. If we take x into y minus z, xy here and y into x here. So plus xy minus xy will get cancelled. So like the denominator value will get 0. So we got here LP plus MQ plus NR equal to 0. Now take LDX plus MDY plus NDZ equal to 0. LMNR here multipliers. Which multipliers? X, Y, Z. So we write x dx plus y dy plus z dz equal to 0. So we can take direct integration. Here we have integration with respect to x. Here we have the variable is x only. So then we can take easily integration. Here we have y dy, z dz equal to 0. Then we can take the integration. X integration is x squared by 2 and y integration is y squared by 2 and z integration is z squared by 2. Here LCM 2. So we can take 2 common and take that side. That will give the constant. P is a constant, 2b is also a constant. So we get the another solution. X squared plus y squared plus z squared equal to another constant, that is b. So this is the second solution. Now write the general solution. Separately 1 and 2 are, those are not a solutions of the given partial differential equations. The general solution is phi of u comma v equal to 0. What is u here? X plus y plus z. This is the first solution. And the second solution is x squared plus y squared plus z squared, which is the second solution. B is nothing but here v and a is nothing but here u. So the general solution will become phi of u comma v equal to 0 by taking multipliers. Sometimes here the two solutions we got from multipliers only. In some cases, one solution we can take by grouping and another solution will take by taking multipliers. But some cases there we have to choose two multipliers, two different multipliers. In the first case, we choose multipliers are 1, 1, 1. In the second case, we choose multipliers are x, y, z. There, what is the condition we have to check? LP plus MQ plus NR must be equal to 0. Then only we write LDX plus MDY plus NDZ equal to 0. So, after integration, we'll get the solution. And before that, we have to consider LMNR multipliers, and those multipliers satisfies the equation LP plus MQ plus NR equal to 0. This is the condition to find the solution of the partial differential equation of the form PP plus QQ equal to R. Now one more problem here we have x into y square minus z square into p plus y into z square minus x square q equal to z into x square minus y square. Now, how we can take the auxiliary equation or substitute equation? The given equation is a standard form only, that is PP plus QQ equal to R. So, which is a linear partial differential equation. We are finding solution of this partial differential equation. So, given equation, write as it is, and first take the subsidiary equations and auxiliary equations. The auxiliary equations are dx by p, capital P, and dx dy by q, and one more dz by r. P, q are nothing but quotient of small p, quotient of small q, and r is nothing but right hand side term. Those are functions of x, y, z only. Now write the subsidiary equations. Dx by p, dy by q, dz by r. Those are functions of x, y, z. Now use x, y, z are multipliers. Why I am choosing here x, y, z are multipliers? If we take L equal to x, M equal to y, N equal to z, then we write LP plus MQ plus NR value equal to 0. That is nothing but denominator. Already here we have x into this one. Multiply L into P. X into x we have x square into y square minus z square plus. What is the denominator condition here? LP plus MQ plus NR equal to 0. L, M, N, R I am choosing. This is our choice. So we have to choose elements are both are either constants or functions of x, y, z. And what is the condition? If we take multipliers like that, then condition is LP plus MQ plus NR must be equal to 0. If we take LX, first condition is x square into something. Second condition plus M into Q. M is y. Y into Q. What about Q here? Y into z square minus x square. Y into y become, we have y square into z square minus x square plus. Another one is NR. What about N here? Z I am choosing. Z into Q. R. What is R here? Z square into x square minus y square. So if we take LP plus MQ plus NR, we have x square into y square is here. Another one is x square into y square. Here minus plus. So similarly, all the terms will get cancelled. So denominator become 0. That is nothing but LP plus MQ plus NR value equal to 0. So if we have like this condition LP plus MQ plus NR equal to 0, then we can take LDX plus MDY plus NDZ equal to 0. LDX plus MDY plus NDZ equal to 0. L is nothing but x. X dx plus y dy plus z dz equal to 0. Take the integration. Integration of x is x square by 2. Integration of y is y square by 2. Integration of z is z square by 2. So here common 2. Take common 2 value and take that side. We'll get x square plus y square plus z square equal to a, which will give the first solution or one solution by taking the multipliers x comma y comma z. Directly we cannot take the solution by using any one of the two fractions, so that we will choose multipliers. So now go for another multipliers. We need two solutions. One solution we got from first multipliers, those are x, y, z. And for the second solution, I am taking 1 by x, 1 by y, 1 by z are the multipliers. Why I am choosing 1 by x and 1 by y, 1 by z? That condition should be satisfied. LP plus MQ plus NR equal to 0. If we take L is 1 by x, P is here x into y square minus z square. Numerator x and denominator x both will cancel. We'll get only y square minus z square. Here we have z square minus x square. Here we have x square minus y square. So all the terms will cancel. So that's why I am choosing L is 1 by x, M is 1 by y, z is 1 by z. So I am choosing 1 by x, 1 by y and 1 by z are the multipliers. Then we satisfied the condition LP plus MQ plus NR equal to 0. If it is equal to 0, then L dx plus m dy plus n dz value is equal to 0. So what is L here? 1 by x dx. What is m? 1 by y dy. And what is n? 1 by z dz equal to 0. Here we have integration with respect to x, and function here we have 1 by x. Similarly, y variable and y function, z variable and z function. So we can directly take the integration. So for that I am writing L dx plus m dy plus n dz. L dx plus m dy plus n dz divided by denominator is Lp plus mq plus nr. L is 1 by x. In the p we have x. So x by x will cancel. So we have only y square minus z square. Second term, z square minus x square. Third term, x square minus y square. So we have Lp plus mq plus nr is equal to 0. If denominator value is equal to 0, we write L dx plus m dy plus n dz equal to 0. So after integration of 1 by x is log x, integration of 1 by y is log y, integration of 1 by z is log z, and equal to, after integration we take some arbitrary constants. Here I am taking b. So we have log a plus log b plus log c form. What is log a plus log b? Log ab. Again plus log c, nothing but log of x, y, z. Log of x, y, z equal to some arbitrary constant. This I am choosing for our convenience. Log some b constant. Both sides log cancel. We'll get x, y, z equal to b. This is the second solution. So now write the general solution. What is the general solution? Phi of u comma v equal to 0. I mean first solution and second solution. What is the first solution? X square plus y square plus z square. And the second solution is here we got x into y into z. So phi of u comma v equal to 0, which will give the general solution of linear partial differential equation, which is of the form pp plus qq equal to r. Here p, q, r are nothing but functions of x, y, z. So here we choose two set of multipliers. First set of multipliers are x, y, z, and the second set of multipliers are 1 by x, 1 by y, and 1 by z. If any multipliers, if we choose multipliers, the condition should be satisfied. That is, Lp plus mq plus nr value must be equal to 0. Like that, we have to choose the multipliers. The condition is okay. Then we write the solution is L dx plus m dy plus n dz equal to 0. After integration, we'll get the solution. So any set of multipliers, sets should be different. That's why we get u is another function, v is another function. So in the first case, I am taking x, y, z multipliers. Then we got the condition which is satisfied, and we got equal to 0. Lp plus mq plus nr value is equal to 0. Similarly, I chosen one more set of multipliers, 1 by x, 1 by y, 1 by z. Then if we take Lp plus mq plus nr, those terms, if we substitute and simplify, we'll get 0. So the condition must be satisfied. Then we write L dx plus m dy plus n dz equal to 0. Then only we can take the integration. So here we have to remember one thing, that is L should be either value of x or some constants. Anyway, constant derivative we can take directly. Similarly, m should be function of y or some any constant, and n is either z variable or constant. So like this, we have to follow and we can find the general solution of the given linear partial differential equation. So here we have to remember phi of u comma v in this form, which will give the solution. Separately, x square plus y square plus z square, which is not a solution, and xyz is not a solution. First take two solutions and write in the standard form. The standard form is here, phi of u comma v equal to 0. So reverse. First, from the function, we solved partial differential equation. Here, from the partial differential equation, we can take the solution of the given partial differential equation, that is phi of u comma v equal to 0. So phi of u comma v equal to 0, and we need only two solutions. So for this problem, we can take another set of multipliers also. Some problems we can get 2, 3, 4 multipliers, set of multipliers we can choose. But here we need only two solutions. That's why we have to choose one set of multipliers and another set of multipliers. Those that should be different. And one more case, in some cases, one solution we can get from grouping if we take either dx by p or dy by q. Now, if it is possible to take first two fractions and take the integration, we'll get one solution. In some cases, we can choose one, two fractions, and after integration, we'll get one solution. For the another solution, we cannot take by grouping. In that cases, we can choose again multipliers. So here we have two types. While grouping, we can take the solution, or by taking multipliers, we can take the solution. So anyway, the procedure of partial differential equation solution is very simple, and we can take two solutions first. One is either grouping or multipliers, whatever it is. Then we can take the two solutions and write the two solutions in the form phi of u comma v equal to 0. U is again a function of x, y, z. V again a function of x, y, z. Anything. Sometimes we have x and z, sometimes y and z, sometimes x, y. There is no problem, but anyway, we need two solutions. Write the two solutions in the standard form only. That is phi of u comma v equal to 0, which will give the complete solution or general solution of the given linear partial differential equation, which is of the form pp plus qq equal to r. This is the standard form. Small p and small q are first derivatives. Capital P, Q are nothing but functions of x, y, z. Hope you all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.